Okay. Hello, I'm Bas Hamer, and today I'll be talking about how I found that BDD and Gherkin, without the BDD part, is actually resulting in quite a bit of happiness. So we're going to be talking about legacy software testing. I will be covering a couple of topics, like what makes software legacy, what tools do we have today, and how can we solve our problems using those tools? And how does that actually result in the creation of happiness? And we'll be talking a little bit about the future, what's possible. So, as everyone who's written software, I'm responsible for legacy software. Right out of school, I built a thing called LogCrab. I was at this company for 2 years total, thereabouts. And before I built this thing, I had written software with a life expectancy of 2 weeks, right? It was homework. And I created this thing in a few months, and it was really successful. And even though I left in 2006, it survived until 2009, and then it was renamed and refactored, and that version lives to this day. So I went from writing software that lasts for 2 weeks to writing software that lasts for at least 15 years in some way, shape, or form. So what makes software no longer die? Well, first of all, virtual machines. Java and .NET, it doesn't tie itself directly to the operating system, so it can survive much longer. Web technology, right? Separating ourselves from the client hardware completely through a web interface makes things pretty much immortal. And if we have internal applications, right? There's no off-the-shelf replacement you can just go to the store and buy, or go to the internet and buy. That makes it survive longer again. And then there's, of course, risk-averse industries, right? Banks, healthcare, government. All of these people don't want to take a risk in rewriting an existing application because they're going to have to debug it all again and they have to do all the learning again. So these applications survive for a very long time. Now, that doesn't quite talk about the issue of legacy yet, because when we look at like old desktop apps, right, they were built for a couple of years and supported for a few more years. They never really became legacy until after that 5-year period. But they were also no longer really supported, so it wasn't much of an issue. But what happened around 2000 is that 10 years of development became like 2 years instead of 5 years, right? And applications stopped dying. So instead of having one person who was involved with development and then maintenance, or maybe a few people, now you have like 7 or 8 generations of developers working on a product. And before that point, nobody knew what it would be like to work on a product as the 5th generation of development. So legacy really isn't so much as an age thing. It's about what's been lost, right? When you turn over generations of developers on a product, they lose the insights of the previous generations. They have to rebuild this knowledge, and you get these misconceptions and superstitions and all the things cropping up because people just don't know why things are the way they are. So we've learned that, and we figured out there's ways to fix that, right? There's TDD, test-driven development, introduced in 1999, right? And the short version is you write your tests before your code, so you don't really get into a position where it's easy to break the software. There's Agile Manifesto was only a few years after that, and it was really about the idea of like, hey, we want to make sure we build the right thing. Right? We don't want to necessarily focus on the process, and we don't want to focus too much on what we documented up front or what we negotiated for. We really want to make sure we build the right thing for our customer, and we do this by doing rapid, frequent feedback. Now, initially, especially, people looked at this and said, this is awesome. We can stop documenting, and we just keep doing the same thing. It's not what Agile is. It's just that in the beginning, it took a while. And then a few years after that, we have behavior-driven development, right? And describing behavior-driven development, there are lots of fancy descriptions. I like to think of it as you create a living, self-verifying document, and you do it before the coding. So now you have this self-verifying wiki, if you will, that describes exactly how the system is supposed to work. So your knowledge is alive and it has an immune system, right? So when the knowledge no longer matches the application, it will tell you, or when the application doesn't match the knowledge, it will tell you that too. But when did we start using these things, right? We didn't start doing TDD in 1999. We didn't look at this thing and said, this is amazing. Same thing with Agile. It all took a while, or BDD. Everything that we figured out, it took a while before we actually started using it. And sometimes it would be decades before some of these things got used. And during those decades, we were, of course, still developing software. So what about the stuff we did before, right? Because TDD pushes the point of legacy further away, right? You make it more maintainable because these test cases are there. Bad Agile brought legacy closer because people stopped documenting. So whenever people left, more of the knowledge left because there wasn't a paper backup. And BDD has the aim of completely preventing legacy because you have that document available, but none of these things really unlegacy the legacy code. And that's the problem. All the technologies and methodologies that we have focus on the loss prevention. They don't really focus on restoration. So let's talk about why we actually care about it, right? And how is legacy different from other code? Well, when it comes to bugs, there's a couple of ways they can show up. And the way I look at it is that the people doing the implementation either understood what they were trying to do, or they didn't understand it, and they executed correctly, or they made mistakes. Right? If they understood what they were trying to do, and they executed correctly, you get working code. That's fantastic. And if they made mistakes, then you get some bugs. But if they didn't understand it and they executed correctly, it still kind of is treated like bugs. And in legacy, this is becoming more frequent. Now, if you didn't understand what you're trying to do and you made a mistake, then who knows what you ended up with. And the technology has really solved this kind of problem, right? Because if you make mistakes and you use TDD, you catch the mistakes and you prevent the issues. And if you don't know what you're doing and you use Agile, you will only not know what you're doing for a couple of weeks. And if you didn't understand, but you're using BDD, chances are that would have been prevented. And you would know what you were supposed to do. So BDD is really honing in on this particular type of defect, bug, that shows up more frequent in legacy software. So how do we apply BDD without a time machine? Those are expensive and or don't work quite the way they were supposed to. Well, BDD is two parts, really. Because you have the BDD, which is the methodology, which you can't use because that's about writing specification before code. And the code was written decades ago, sometimes. But there's also the Gherkin part, which is technology, right? We can just use the Gherkin and still gain some of the same benefits by building a domain-specific language. Now, there's a couple of reasons you want to use a domain-specific language. First of all, it's accessible. Right? It feels much more like configuration versus coding, which is really important when you don't all have coding skill sets. And it's humanly readable, so it reduces these misunderstandings. And everyone can use them, right? Our parents can use them. Our parents do use domain-specific languages. This is Alexa English. Alexa commands are a domain-specific language. They're actually surprisingly similar to Gherkin, except for given when then, we have Alexa, Alexa, and Alexa. But it's the same idea. So we can write tests like this, right? This is a simple let's Google something test. And we can just create this generic language that can navigate through our application and people can use these things. But there's a couple of problems with Gherkin. First of all is maintenance. If you have working on larger projects with Gherkin, you will notice that there's a lot of steps. And that becomes a hard problem on the maintenance side. The other thing that's going on is that the IDE is not fantastic. It's really not intended for writing it in it as a domain-specific language. It's really more meant for writing in it as a specification language. Now, on legacy software, we kind of know the specification, or at least people who have been at the organization for a long time know the specification. We're just trying to capture an existing specification and then generate all of the test cases from that rather than going the other direction. Now, the first thing we can solve by having more powerful steps. So here's an example of how you can use variables. I've talked on this topic before. And this reduces the number of steps, right? We're kind of taking this thing and we're taking a step closer to a programming language. And because by taking a step closer to a programming language, we can now, use properties of variables, and we need fewer steps to do the same amount of work because we can just access these properties. And there's lots of different ways we can use this to build hierarchical data. And it makes it much more powerful, and we end up with far fewer steps in the end. The other thing is the tooling. It is Visual Studio. I love Visual Studio. If you learn to code, do not use Visual Studio. It has an extremely high barrier to entry because it does everything. And then some. Like, I probably only know 2 to 5% of what Visual Studio can do. And that's a lot. And I have no interest in learning the other 95% because it's just too much. That's the problem with these tools. These tools are built for everything around development. And they're not really built to solve our particular issue. Because what we want to do is we want to configure, we don't want to code. And people configure quite a lot these days. Even non-technical people have had a PC for 20 years, have had a smartphone for about 10 years. They configure stuff all the time. They just don't want to code. They don't want to do the abstraction and the thinking around it, and you look at it and it's like, oh my god, this is hard, and I can understand that. So Gherkin is amazing for legacy software, but the tools could be better. Like that's really the biggest barrier to entry. Now, I talked about happiness, and being a legacy QA, of legacy system QA, happiness can be a little hard to come by, right? We often have bad news because everything in legacy systems takes longer than we expect, and we quite often come back with really bad news because sometimes somebody built the wrong thing. It means we pretty much have to start over, right? And these systems, especially when they are installed with customer sites, are usually very configurable, and that makes it even harder to figure out exactly what's going on. Because let's look at this page. This looks like a very nice, simple configuration page on how we set the settings. Now you can look at that and say, like, well, it looks pretty clean, it doesn't look too abundant, but when you start thinking about it, ooh, that is a lot of different possibilities. There's no way in hell we can test that. But if you're not working in QA, you look at that page, you're like, doesn't look that bad. Now we know we don't have to test all of these configurations and all the interactions between them, but it takes a little bit to figure out exactly which interactions do interact together and which ones don't. And sometimes we find a bug and then try a customer, and then we learn, oh, these two things do kind of interact behind the scenes. And we have to expand our testing scope. Now, if we want to get to happiness, we can kind of treat it like a project. We can break it down, right? We can break it down and say, like, well, these are different parts we want out of our experience working in QA. Now, this is from a particular acronym, and the order doesn't really work out, so we're going to start with relationships. When you are creating a domain-specific language, you're going to have to seek out the information, and that means you're going to be talking to people all across the organization. The nice thing is that you're going to capture this information, right? Capture these stories, and you're going to preserve them, and you're going to validate them. And what you're doing is you're creating this institutional knowledge base for the organization. It's a bit of a different definition as to what people normally would associate with QA. And the organization can understand these test cases, right? It's not just a check mark anymore. It's this much more like a wiki that people can go to, and people know that what they read in the wiki is true because it's validated. And the organization can see the wiki grow because it's English and they can understand it, right? And when you're writing these test cases, it's really fast, right? The more powerful your domain-specific language is, the faster it is, because you have bigger constructs you can reuse to set up entire parts of the system and get them in the right state and dig into the nitty-gritty and actually build those things out. It is awesome. And what's changing is that QA really isn't a cost center anymore, right? We're not the people who say no, and when something goes wrong, people complain, and when things go right, people wonder whether or not we're paying too much for QA. Right? We become the lore keepers of the organization. And that's much more important to the organization, much more valuable. And it means that we become more valuable, which is very nice. Right? So we can build happiness by breaking down the parts and building something better. And that's what I've been seeing in a lot of the organizations I've worked at. It is actually kind of nice. part of the reason I'm still doing this and didn't go back into development. So I am still a developer at heart, and that means I always want to make things better. And we know that the tooling is not ideal, and we know that for the tests to work well in the organization, we need better discovery. And we also understand that when an organization transitions into automated testing, we want to make sure we offer strategic reporting, right? This means like what happened in the last quarter, what happened in the last year, rather than what happened in the last build. And we also know we can kind of cheat, right? Because we don't really need the tools the way they are. Test cases have some very odd characteristics as far as code is concerned. They don't loop much. They don't branch much. There's very few for loops or for each or if-else statements. I mean, you have like an assertion at the end, but that's usually about it. And if you look at automated test cases from far away, you notice that the indentation level doesn't really change. You can kind of identify whether or not somebody is looking at test cases just by a glance at the code without even having to read anything. And we also want to make sure we can serve the business users, because the business users are the people who stay the longest at organizations. Technology staff turns over very quickly. We want to make sure that they can get into these tests and they can understand them, they can validate them, and they can appreciate them, because then they will appreciate us more. And this is what I ended up with after people told me this was impossible. So this is an online editor, right? You have the same idea. You still have the gherkin. You still have the same constructs in there, but we make the steps discoverable. Rather than starting to type and having the autocomplete, you can just type in the thing you're interested in, and it will filter down the given one then steps, and it shows you what steps are available. Right? You can edit things, and you can see exactly what is going on. We can autocomplete things, because we know that the only way to get to step 4 is from step 3. The only way to get to step 3 is from step 2. So why not be debugging as people are writing it, so we can autocomplete things with the fields that are available on the screen. Right? So that's why you end up with an editor like this. And that's where the future, I hope, is going to go. Let me know if you have any questions.